So we are going to talk about our second kind of big section of the immune system, the adaptive immunity. And this is kind of what we refer to as the second line of defense. And adaptive immunity really revolves around the fact that the body does at some point have to learn new antibodies. And so how does it do that? So remember that we're going to encounter pathogens throughout our lifetime, and some of them we will know because we've encountered them before, but some we will be new to. Some of them will be new to us, and so we have to learn how to defend against those. And the way that our body defends against antigens is through antibodies. So we have to learn how to make new ones. So what are the steps when your body doesn't already have antibodies? So we have the initial steps here. The initial steps revolve around a cell engulfing a pathogen, that pathogen being broken down, and then something interesting is going to happen. We're going to take pieces of that pathogen, those antigens that we've talked about before, and we're going to place them on a protein. That protein is called MHC, that's major histocompatibility complex, which you just have to know MHC. And then we're going to move that MHC to the surface of the cell, and we're going to wait. And what we're waiting for is a T cell to come around and check our MHC. If the T cell says, hey, I don't recognize that antigen, it's going to kick into gear to do the second stage of learning an antibody, which we'll come back to in a second. So who can be involved in this initial process? Who's going to be engulfing pathogens, breaking them apart, and then placing their desiccated pieces on a protein that they then display on their cell's membrane? Well, this can be done by macrophages and monocytes. You can see that those are going to come up a lot. We're going to see them a lot. This can also be done by a B cell. A B cell is a new cell we have not talked about yet. So I want to talk a little bit about a B cell. So a B cell is a type of white blood cell that is going to go through phagocytosis. It can also phagocytize. And we can also see this with a normal body cell. A normal body cell can also phagocytize and display pathogen pieces on its surface. But the thing I want you to remember is that there are different types of MHC. There are two different versions of MHC. There's MHC class 1 and MHC class 2. And where those get displayed is unique to them. So if you would head to your glossary, and if you would find page 5 in your glossary, you will see MHC class 1 and MHC class 2. So MHC class 1 is an antigen carrying protein, and that is found on body cells. So any body cell is going to have MHC class 1. The only body cells that will not have MHC class 1s are red blood cells, and they have a whole different thing. So we're not even gonna worry about them for right now. MHC class 2s are also antigen-carrying proteins, but they're found on B cells, dendrites, and macrophages. So those are the things that are going to carry MHC class 2. An easy way to think about this is MHC class 1 is body-wide versus MHC class 2 are reserved for your immune system. And while we're here in the glossary, let's flip to page 2 and write down some definitions. So starting with a T cell up at the top of the page, the T cell is the inspector of MHC. Then we have a naive B cell, which is the phagocyte, and remember that it presents MHC class 2. So MHC2, so you can say this is the phagocyte that presents MHC2. You could also talk about dendritic cells at this point. Remember, this is going to be a phagocyte in tissues that enters the lymphatic system. And this is the most effective antigen presenter because it can present both MHC class 1s and MHC class 2s. So it can show a whole bunch of new antigens. Just double checking to see if there's any of the other ones we want to talk about, and I think that's it for the glossary right now. Okay. So just remember that making the new antibodies is going to involve both MHC class 1 and MHC class 2. So now let's focus on the actual making of the antibodies. So now we've learned how we recognize foreign or new antigens. We do that through the T cell reading the MHC proteins. But now what do we do? So now the T cell knows that we have an infection. What do we do now? And this is where the next stage of the response comes in. So the T cell is going to read the MHC proteins. And when they do that, they are either going to become a helper T cell or a cytotoxic T cell. The cytotoxic T cells are going to kill the infected cell. They're going to cause it to go through apoptosis. The helper T cells, those are going to continue this process of making antibodies. They're the ones who are going to move on to that next stage. And that next stage is activating B cells. So when a B cell is activated, it's going to go through mitosis. And when it does, it has two possible pathways. It can become a plasma cell, or it can become a memory B cell. Plasma cells make thousands of antibodies a second. They are antibody making machines. The memory B cells, on the other hand, are going to remember how to make that antibody forever. MHCs also play a really important role in recognizing healthy cells. So natural killer cells don't have the ability to like learn anything from MHCs like T cells do, but they do recognize whether or not a cell is healthy. So sometimes when a cell is infected, the infection will cause it to stop making MHCs. So the natural killer cells come along and they're checking and they're like, oh yeah, there's an MHC here. So I'm just going to leave this cell alone. But down here, you can see the natural killer cell goes to look for the MHC and it's not there. So what it does is it kills the cell. So MHCs not only help us learn new antigens, but they also help us sometimes just tell whether or not a cell is healthy or whether it's been infected. Once we have activated B cells and we have either become a plasma cell or we've become a memory B cell, those B cells are going to hunt down those antigens. They're going to start looking for them. And anytime they come in contact with this antigen, it now knows what it needs to do. And it will proliferate into either a plasma cell or a memory B cell. So this is how you can kind of ramp up your immune response. So as a B cell comes in contact with the antigen, it's going to continue proliferating into more and more plasma cells that release more and more antibodies. And that's what we call the primary response. So this is an initial encounter with a infectious agent, a new antigen. And then each subsequent time that a B cell comes in contact with that antigen, it's going to make plasma cells. It's going to divide and it's going to make memory B cells and it's going to make plasma cells. So we can remember these antigens years down the line because memory B cells are constantly checking to see if an antibody they know how to make is present on an antigen, or present on a pathogen, I should say. And then what do we do? What do we do now that we have new antibodies? We do the same process we talked about in our last lecture. We do neutralization, we do agglutination, we do precipitation, and those all lead to phagocytosis. So just kind of a refresher of like, what is this all leading to? What are we trying to get to? We're trying to get to this response. We're trying to get to the point where our cells recognize that we have an infection and just phagocytize it away. And this is where we really finish off the two sections of our defenses. The innate defenses that stand vigilant all the time, that know how to defend against invaders, and then our adaptive defenses that learn new pathogens as we come across them. So I want to round this out by kind of going through our glossary and making sure any new terms that we learned got hit. So if you turn to page 2, we've already talked about T cells and naive B cells. Let's do memory B cell. That is a cell that remembers how to make an antibody forever. A plasma cell is an antibody-making factory and makes hundreds of antibodies a second. The downside is they are very short-lived. They don't have a long lifespan, which is why we need those memory B cells to remember how to make those antibodies forever. We talked about a dendritic cell already. Let's look at natural killer cells. Remember that these are cells that are looking for infected cells, but really what they're looking for is cells that are not presenting MHCs, and it destroys those. So the cells that fall under this category are cells that are infected with viruses or cancerous cells. Cancerous cells are so focused on going through mitosis that they don't display MHCs. And because of that, natural killer cells recognize them and kill them off. All right, and I think that is everything for this lecture.